In this video, we'll be looking at the concept of ionic bonding. Ionic bonding occurs between metals and non-metals. Ionic bonding is a bond purely held by the electrostatic force of attraction between the opposite charges. Let's understand the ionic bonding with an example. The example we are going to take is NaCl. NaCl is nothing but table salt. NaCl is made of two elements, sodium and chlorine. Sodium has 1 electron in its valence shell and chlorine has 7 electrons. Sodium wants to give away 1 electron and chlorine wants to take in 1 electron. So it is simple here. Sodium will release its electrons and become stable. The electron that sodium releases will be taken in by the chlorine and it will also become stable. At this point, both of these elements are not present as atoms. Sodium will exist as an ion with a charge of 1 plus and chlorine will exist as an ion with a charge of -1 minus. Since opposite charges attract, both of these ions get attracted to each other and stay close. This attraction between the ions is the bonding itself. Now let's take a look at another example. Suppose let's take magnesium and chlorine. Over here we need to create a compound using these two elements. The first thing we need to do is to find the number of valence electrons of each of these elements. We'll take the structure of chlorine. Over here we need to look at the number of valence electrons. Chlorine has 7 valence electrons. It's written over here 2, 8, 7. It has 2 electrons in its first shell, 8 electrons in its second shell and 7 electrons in its third shell. This is known as the electron configuration. We have first shell, for the first 20 elements you have 2 electrons, and the second shell should have 8 electrons and the third shell should have 8 electrons. Over here the third shell has only 7 electrons, so it will gain 1 electron. So chlorine would have a charge of -1 minus when it gains an electron. Now let's look at magnesium, which is the other compound we're looking at. Element, not compound. Magnesium has 2 valence electrons, that is 2 electrons in its outermost shell, 2, 8, 2. So it wants to give away these 2 electrons to attain stability. If magnesium gives away 2 electrons, chlorine only wants 1 though. So what we are going to do is take 2 chlorines instead of just 1 chlorine. If 2 chlorines react with 1 magnesium, we'll get MgCl2 because magnesium will give away 2 electrons. Chlorine will take one chlorine atom will take one of those electrons, another chlorine atom will take the other electron. And we can also balance the charges. Every compound should have a net charge of 0. Magnesium ion will have a charge of +2, 2 plus. Chlorine, 1 chlorine ion will have 1 minus, 2 together will have 2 minus. -2 plus 2 is 0. It has a net charge of 0, so we can confirm it that way. Let's look at one last compound. The 2 elements we are going to take are sodium and oxygen. Right now, we should be able to take the 2 elements, look at the number of electrons and find the number of valence electrons without the need of diagrams. To learn how to identify the valence electrons, we need to know the electron configuration. We looked at it in one of the diagrams. The electron configuration is 2, 8, 8, 2 for the first 20 elements. We can leave the last shell. Based on this rule, we need to identify the valence electrons. Sodium has 11 electrons. So the first shell will have 2 electrons, second shell will have 8 electrons, that makes a total of 10. And then we have 1 electron left that will go in the third shell. So we have an electron configuration of 2, 8, 1 for sodium. It is 2, 8, 1. That is the electron configuration of sodium. Now we need to look at the other compound that we have, other element that we have, and that is oxygen. Oxygen has 8 electrons. We can fill the first shell with 2 electrons, and then if we remove 2 from 8, we have 6 left, and that will go in the second shell. So we have 2, 8, 2, 6. We have 8 in total, so 2, 6. So oxygen wants 2 electrons, while sodium wants to give away 1 electron. Again over here, sodium is going to only give away 1. One sodium atom can only give away 1, while oxygen wants 2. So what we are going to do is take 2 oxygen atoms instead. So our compound, we are going to take 2 sodium atoms, not 2 oxygen atoms. So compound will be Na2, Na2O. Now we can also balance the charges over here. So 2 sodium atoms in total will have a charge of 2 plus, while 1 oxygen atom, which is reacting over here, will have a charge of minus 2. So it will be plus 2 minus 2, and that gives us a net charge of 0. So it is a compound. We can confirm that. Now we have learned the basics of ionic bonding. Let's look at properties of ionic compounds and their structures. This is known as a lattice structure, and this is the structure ionic compounds are present when they are in solid state. In an ionic lattice, there are so many cations and anions. Cations are positively charged and anions are negatively charged. Each of them are surrounded by ions of the opposite charges, and they're all attracted to each other. And this is what we call as ionic bonding. And this ionic bonding gives the ionic compounds the properties they have. Ionic compounds are solid at room temperature. This is because the ionic bonds are very strong, so it requires a lot of energy to break this bond. So they are high boiling and melting point, so they are solid at room temperature. Ionic compounds are generally solvable in polar compounds like water. Since the bonding is just attraction of charges, when it is added to water, water also has positive and negative particles, which will also attract the ions in the ionic compound. This allows the different elements to kind of split apart, and this is what we consider as dissolving. It slowly dissolves in the water. Ionic compounds are good conductors of heat and electricity in liquid state, not in solid state, because they have charged particles and they can move around freely in liquid state when there is no lattice structure present. But in solid state, there is a lattice structure, and these ions are not able to freely move around, so they can't conduct heat or electricity. This is all for this video. Thank you so much for watching. Subscribe to our channel, like the video, and comment down your thoughts and doubts.